Chapter 1 Introduction to Digital System. Okay, the purpose of this class is to study the engineering method to design digital circuit. Namely, you should know how to design, how to implement, and how to test the digital circuit. Okay, so you should know and understand the properties of each element to implement the system. For example, you should know the property of logic gate, maybe AND gate, OR gate, or inverter. And you should know the behavior of the system, okay, when you take element, okay, connect together. Okay, for this system, let's consider this one. Okay, normally in electrical system, there are inputs variable or input signal and output variable or output signal. For input variable or independent variable, namely each value, okay, independent from the system, like computer, okay. The computer cannot control the user, okay, to key, okay, the input A, B, C, or 1, 2, 3, right? But the computer can control the display, right? The output. So output is dependent variable. And furthermore, some system have got state variable. Okay. For the detail, you will study later after midterm examination. Okay, the second part of this course. Okay, let's compare between analog and digital system. For analog system, the value of signal like voltage, okay, maybe in continuous range. But in digital system, there are only two possible values, okay, discontinuously. Okay, let's consider this one. This one, if you treat as analog signal, what happened? This point, this value may be 0, 1, 2, 3, 4, maybe 4.4 volt. And this point may be 1, 2, 3, 3.8 volt. Okay, in analog world, it's different, right? It's different. That means if you send the signal voltage from the transmitter is 4.4 volt and the receiver get 3.8 volt. I mean, it's different, right? Some error occur. Anyway, in digital world, we define the length of the signal. If the strength of voltage or voltage potential is between 2 and 5, treat as logic high, and between 0 to 8 is logic low. That means if you send 4.4 as logic high and the receiver get 3.8, okay, which are different in analog world, but in digital world 3.8 still be logic high also. That means there is no any error in digital system. Okay, for logic low also it may be 0 or 0.5. okay, there is some gap, okay, that can cover the logic high and logic low value. Anyway, the value between 0.8 to 2 volt is invalid, not high, not low. That means in practical, the voltage, okay, for logic high and then change to logic low, of course, it must pass through this invalid range or undefined range. So you must design the system that pass this point of time as fast as possible. Namely, it should be as short as possible for this transition between low to high and high to low. Okay. Now, it's called noise tolerance. Okay, it's advantage of digital system. Okay, because if some temperature change, the voltage may be changed, maybe from 3.5 volt. Some temperature change, maybe it's go to 3.8 or 3.7 volt. Okay, with different in analog world, but in digital it's the same. Okay, logic high. So digital have good noise tolerance, and digital system is easy to design. Okay, use just simple mathematics, okay, to design. No integration, okay, no differentiation. It's very easy and programmable and flexible. Okay, high speed, safe. Okay, small size, but it can do various functions. Okay, and then it just show some development for the past. For the original computer, it's very big size, but nowadays, okay, 60 years ago, okay, it's very big size, okay, room size computer. But nowadays, okay, it's laptop, right? Very small size, or in smartphone, just very small, about hand size. Okay, for digital device, the basic device is logic gate that you will study. Logic gate, and after midterm you will know the flip-flop. Okay, at the midterm, before midterm you will study this part. Okay, combinational circuit. After midterm examination, we will study sequential circuit. What difference between combinational circuit and sequential circuit? For combinational circuit, for example, this one, if you apply input to the digital system, the first thing, okay, the value of digital system, okay, its signal or its variable can have only two values, namely low or high. Sometimes we write 0 for logic low and 1 for logic high. That means, okay, it may be apply 0, 0, 0 at here, and output maybe have 1, 2 bit, or maybe 0, 1, for example. If I apply input 1, 1, 1, okay, output may be 1, 1. And if I apply 0, 0, 0 again, the output must be 0, 1. Namely, if you apply the same input value, you will get the same output. Okay, this is the point. Okay, the basic property of combinational circuit. Okay, same input will give the same output. Okay, but for sequential circuit, okay, there, for example, okay, you know TV remote control, right? Remote controller, okay, for TV remote controller, and there's some many key, right? Many button, maybe you have number 1, 2, 3, and so on, right? If you press number 1, for example, your television will show channel 1, right? Okay, if you press 2, it shows channel 2. If you press 3, it shows channel 3. And when you press 1 again, it shows channel 1. Okay, this kind of behavior is like a combinatorial circuit. Okay, same input, okay, give same output. But if you consider this bottom, okay, channel increase, okay, up and down, okay, increase and decrease channel of television. What happened? Assume now it's channel 1. If you press up, then it change to maybe channel 2. If you press up again, it go to channel 3, right? Channel 3. Same input, right? Up, okay, up, but different output. Okay, and if I continue, key the input up, down, up, down, up, down. Okay, what the result? If I continue from channel 3, so it's go to 4, 5, down to 4, up to 5, down to 4, up to 5, up to 6, down to 5, right? So you know the result. You must know the sequence of input. So this kind of circuit is called sequential circuit because the output can depend on the sequence of the input. Anyway, in practical, it's possible, right, to memorize all the sequence of the input. Okay. So for sequential circuit, okay, it create one more variable. It's called state variable. Okay, to keep the state, okay, to represent the result of the previous sequential input. For example, if you know that the current state is channel 5, that means you need not to know the previous input sequence, right? You just know that if the next input is down, so you can tell the next channel, okay, should be 4. Okay, if you know current state and you know the input, so you can know the next output and next state. Okay, this is sequential circuit. Okay, to implement sequential circuit, you need to use flip-flop. Okay. Anyway, for now, okay, just focus only on combinatorial circuit. Okay, that use only logic gate. Okay, and the basic logic gate. The first one is 2-input AND gate. Okay, the function is follow this two table. Namely, maybe in high school you already study about logic, right? For example, 2 and 2, okay, give 2 as a result, right? Here, for this class, okay, I use 1, logic 1 for 2 and 0 for false. So for AND operation, okay, the output of AND gate will be 1 just only when input x and y is 1, 1. Okay, if one input is 0, the output will be 0. Okay, for logic symbol we use this one. Okay, and this curve. Okay, and for equation, okay, in algebraic term we use dot or multiply for AND because it is similar multiply, right? For multiply 0, 0, 0 multiply 0 is 0, 1, and 0 multiply 1 is 0, 1, 0 multiply together is 0. Okay, when you multiply 1, 1, you give 1. Okay, so we just use multiply for AND operation. And consider this one. If this input is constant 1 and this input came 0, 0, 1, 1, 0, 0, how about the output? Okay, if 0, this one, so output is 0, right? If this one is 0, output is 0. If this 1, output is 1, input 1, it's 1, right? Because 1 and 1 is 1. 0 and 1 is 0. Okay, and so on. So if this input is 1, okay, we look at this sequence of input can go out to the output. But if this input is 0, 0 and 0 is 0, right? 0 and 1 is 1. Okay, so output is 0. So this acts as gate, right? To control by this input value. If this input value is 1, input can flow, okay, go to the output. But if this input is 0, this input sequence cannot go to the output. Okay, so it's called logic gate with the condition AND. Okay, the next logic gate is OR. Okay, for OR gate, the output will be 1 if one of input value is 1. The output will be 0 when both input is 0. Okay, we use this as logic symbol for OR gate, and we use plus, okay, sign for all operators. Okay, because 1 0 plus 0 is 0, right? 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 2, but 2 also is high, right? Because digital system, it can have 0 or 1, right? So it's 1 at here. So this is operation. For operation, okay, if input is 1, okay, 1 or anything is 1, right? So it's constant 1. But if you apply this constant 0 and change sequence of input for this, so the output should be what? 0 or 0 is 0, 0 or 0 is 0, 0 or 1 is 1, 0 or 1 is 1, 0 or 0 is 0. So this output can flow to the output if this control signal is 0. If this control signal is 1, the output cannot go. So it's like a gate, right? To control the signal can flow to the output or not, but different condition for AND gate and OR gate. And the next one is inverter or NOT gate. Okay, the output will be opposite to the input. Namely, if input is 0, output will be 1. If input is 1, output will be 0. Okay, and for the logic symbol, we use triangle and circle. The main point is this circle. This circle sometimes is called inversion bubble. Okay, to operate invert. Okay, and about this, in mathematics equation, we use x prime or x bar. Okay, and your high school will be use this, okay, till something like this. Anyway, for this textbook, we often use this one. Okay, x prime or x dash. Okay, to show invert or not operator. And the next one is NAND gate. Okay, you know NAND gate? Okay, NAND is form not. Okay, not of AND. Okay, in circuit diagram, okay, you invert output of AND by NOT gate. So for convenience, we keep already this inversion bubble attached to the output of AND gate. So this is symbol of NAND. Okay, not AND. That means the output of NAND gate will opposite to AND. For AND, output is 0, 0, 0, 1, right? For NAND, output is opposite, then become 1, 1, 1, 0. Okay. The next one is NOR gate. NOR, not OR. Okay, not of OR. Okay. Then output is opposite to OR. For OR, output is 0, 1, 1, 1. For NOR, output opposite, then become 1, 0, 0. Okay. So for the mathematical expression, we should invert of and for NAND, and invert of OR for NOR. Okay, use parentheses, okay, to group this. And XOR. XOR is from exclusive. Okay, exclusive. Okay, so XOR is exclusive OR. So the result quite be the same as OR. For OR is its output is 0, 1, 1, 1, right? But for exclusive OR, it's different in this case. Namely, it's not 1. Okay, it's changed to 0. It's XOR. For XNOR, it's exclusive NOR. Okay, similar NOR except this case. Okay, for this case, it's not 0, it's go to 1. So then it becomes this. So, and take a note. Okay, take note. For logic symbol, we use OR and add this curve. Okay, add the input for XOR gate. And for mathematical expression, we add circle allow plus sign for XOR operators. And please note, in two tables, for XNOR and XOR, it's opposite, right? 0, 1, 1, 0. This one is 1, 0, 1, 1, opposite. And if you note that this one, the output will be 1 when value of input x1 is different. But for XNOR, if x1 is different, output will be 0. Output XNOR will be 1 when xy are the same, 0, 0 or 1, 1. But XOR, if input is the same, output will be 0. So the logic symbol we use inverse bubble at the output of XOR to represent XNOR gate. And for mathematical expression, we use invert of XOR. And for someone, maybe use circle around AND. Okay, because it's similar to AND, right? Just change this one. And the last one that I want to introduce you is buffer. Okay, buffer. And logic input and output are the same. Namely, if you apply 0, output will be 0. If you apply 1, output will be 1. Okay. Okay, for the logic symbol, use this one. Okay. For this one, it is used to produce the signal that have more state. For example, if I apply, for example, the input apply 3.8 volt, which is logic high, right? But the output same logic high. Okay, input is high, output is high, but output may be 5 volt. Okay, more state of voltage level. That means, for example, if your circuit, this part, okay, send signal to another part of the circuit, the voltage will be dropped, right? From 5 volt to 3 volt at this point. And if you use this distribute to another logic gate, it may drop down to 2 volt or lower than 2 volt, which is invalid, right? Invalid. It cannot treat it as logic high. In this case, you can use buffer. Okay, buffer. For example, I add buffer at here, 3 volt, then it up state of signal to 5 volt. So now you can distribute this 5 volt to another logic gate. Okay. Okay, to make the signal stronger potential. Okay, and this one just show what, because the value of variable can be only 0 or 1, right, for this system. That means it's a finite function that can be, for example, for one input and one output. It may be what? Because one input can be 0 or 1, right? Output may be 0, 0. If you apply 0, output may be 0. If you apply 1, output may be 1. Okay, the second function. Or the third function, if you apply 0, output is 1. Apply 1, output is 0. Okay, invert, right? And the last possible function is what? 1, 1. Okay, namely output will be always 1. Okay, even x is 0 or 1. Okay, so there are 4 possible functions. Okay, next. And this picture shows some spec of IC. Okay, IC is from integrated IC, right? The IC, okay, next page. This IC, internal IC maybe contain 4 or more logic gate. Okay, for example, the IC number 7400 contain 4 NAND gate inside. For 7402 contain 4 NOT gate inside, and 046 inverter inside. Okay, the IC that contain fewest number of logic gates called small scale integration. Okay, SSI. If the IC contain in around 100, okay, logic gate inside is medium size, and it 10,000 or more, maybe very large scale integration, and if it's more than million, it's very large, okay, very large scale integration, or VLSI. Okay, to implement the digital circuit, okay, you may use logic gate, or nowadays, okay, you can implement by using programmable device such as PLD or FPGA. Okay, and to design, there are many levels to design. For this class, okay, maybe just focus on logic gate design level, namely, and you just take AND gate or inverter, okay, to connect together to implement the function that you want. Anyway, we also study in transistor level a little bit, and apply more complicated in IC a little bit. Okay. If you want to design in very low semiconductor physical level, it also have some subject like VLSI. Anyway, for this class, focus on this. Okay, it's basic that you should know and understand well. Okay, and this one just example for the circuit that you will study for this class. For this one, it's called multiplexer. Multiplexer, there are 1, 2, 3 input and 1 output. Okay, this input is treated as data input, and S is control input. Okay, they use to control that which one can go to the output. For example, if S is 0, output Z will be the same as A, right? 0, 0, 1, 1, 0, 0, 1, 1, okay, same as A. Okay, but if S is 1, data from B will go to the output. Okay, if B is 0, output is 0. If B is 1, output is 1. So this kind of circuit is called multiplexer or MUX. Okay, to represent this one, you can draw this truth table, or you may use commercial available IC, okay, 157, or you can implement by using programmable device with VHDL, okay, hardware language, or use logic gate, okay, connect together like this, namely, for example, uh, from this one, if S is 1, this output of inverter, if S is 0, output of inverter is 1, this one is A, right? A and 1 is A, right? This one is B, 0 and B is 0. A or 0 is A. So when S is 0, okay, data input A will flow to the output. Okay. On the other hand, when S is 1, what happened? This output is 0, 0 and A is 0. 1 and B is B. Okay, B or 0 is B. So now when S is 1, the data input from B will go to the output. Okay, this is multiplexer that implemented by logic gate. Or in transistor level, also will be studied by using transistor to implement the multiplexer or another kind of logic gate function. Okay, that's all for today.